Alright, so we're on question 3 of homework 11, and basically we're trying to find the expectation of a geometric distribution. So question 1 basically lays the foundation, part 1 lays the foundation for this, for the entire question. Part 2 trivially follows from part 1. So question 1, we're trying to prove that sigma s is equal to sigma I is equal to 1 to infinity. This is called an arithmetico-geometric progression, where you have elements of both geometric progression and an arithmetic progression. So you see the coefficients of the geometric progression actually is an arithmetic progression in itself. So if you don't know what an arithmetic progression is, it's just a series of numbers such that each and every consecutive, any two consecutive numbers differ by a constant number. Or the difference between any number and the next number is always going to be a constant. And geometric progression is the factor, each and every consecutive number is a constant multiple of the previous number. So basically you have 1 r squared all the way onwards. That's a geometric progression. 1, 2, 3, 4 is an arithmetic progression of a common difference 1. So this is an arithmetico-geometric progression, and we need to prove that the sum of this particular expression is this thing given here. So how do we go about doing that? So we have IR to the I is equal to 1 plus 2R. I'm just going to restate the question. And we have mod R less than 1. This is important, and I'll explain in a bit. So now let's actually work with what the hint says. The hint makes it very simple for us. So it says, what is S minus RS? It actually asks us to take S and then subtract RS. So what I'm going to do is I'm going to write S on top and then RS below. So we have 1 plus 2R plus 3R squared all the way minus R times S, which is R times 1 plus, sorry, not plus, this is minus R times 2R, which is 2R squared minus, and so on. So you see this 1 gets carried down as 1, and then 2R minus R gets carried down as 1R, and then 3R squared minus 2R squared gets carried down as R squared. So this goes on, and we get R cubed all the way till infinity, which is equal to sigma I is equal to 1 to infinity R I minus 1. Now in arithmetic or geometric progression, the sum of a geometric progression which starts with the number a and takes this form, AR squared all the way till AR to the n minus 1. Oops. R to the n minus 1. So this is an n term. These are n terms of a geometric progression. The sum of these terms is given by a times r to the n minus 1 divided by r minus 1, which is equal to obviously 1 minus r to the n divided by 1 minus r, right? So this thing is a geometric progression. This is a note on the side. This thing is a geometric progression with common difference with the factor r as r itself, and a is equal to 1. This is equal to 1 times 1 minus r to the infinity divided by 1 minus r, which is equal to r to the infinity. Since we know the magnitude of r is less than 1, r to the infinity is going to be 0. So 1 minus 0 is just going to be 1, which is equal to 1 over 1 minus r. So we have S, therefore we have S, get this properly, S times 1 minus r, right? This is S times 1 minus r is equal to 1 over 1 minus r, which is equal to 1 minus r, which implies S is equal to 1 over 1 minus r squared. So another way of looking at this particular expression is you have, well, actually it's exactly the same thing as here, but you know that 1 minus x to the n divided by 1 minus x is equal to 1 plus x all the way till 1 plus x minus n minus 1. So you can use the same technique here, and then you have x over here as r. Therefore, it's equal to 1 minus 1 x to the n divided by 1 minus x. If x is less than 1, this thing goes to 0. If the magnitude of x is less than 1, this thing goes to 0 as n tends to infinity. Well, it's the same thing, but you look at it without needing to use a, without needing to look at it in terms of a geometric progression, even though this is exactly the same thing. So if you think it's slightly more comfortable looking at it that way, then yeah, so there's a standard formula which says that 1 over 1 minus x, if x, magnitude of x is less than 1, is equal to 1 plus x all the way till infinity, x squared all the way till infinity. So this is a standard formula if you don't want to go through the mess of a geometric progression. Alright, so let's just move on to part 2, which actually asks us to find the expectation of a geometric distribution. Okay, I'm just going to clear this part out first, and I'm going to make use of this space, right? First of all, the question mark here, okay, I guess I can't erase that. Question mark here is just equation 1. So now we want to find, okay, so first of all, what is a geometric? A geometric with a parameter p, okay, I'm just going to write this again. X, geom, p. The geometric distribution is such that probability of x is equal to some positive integer I is equal to. It fails. So basically, this is basically telling geometric distribution is a distribution which measures something like when is the first time you will succeed. If each and every time you toss a coin, when is the first time you get ahead? When you get heads. So that's what a geometric distribution is. It looks like intuitively. So probability of x is equal to I is that it has to fail I minus 1 times and succeed the last time, right? So this probability of this is a geometric distribution. Now an expectation of a geometric distribution is equal to sigma I is equal to 1 to infinity, because you can actually you potentially could fail an infinite number of times. Basically, you can never succeed. That's it. With probability 0, it can occur, in the sense that a way of thinking about it is that there is a small chance that you will go a long time without succeeding. So we have to sum all the way till infinity, because as long as even for very large numbers, even though the probability would be minute, as long as p is not equal to 0 or 1, there's always going to be some probability. So we have to sum all the way till infinity, which is probability of x is equal to I times I, which is equal to sigma I is equal to 1 to infinity 1 minus p to the 1 I minus 1 times p times I. I'm going to pull the p out, so this is equal to 1 sigma p times sigma I is equal to 1 to infinity I times 1 minus p to the I minus 1. So what do we just prove in the part? Oh, okay, so in the question there seems to be I think I made a mistake over here too. So in part 1 I seem to have made a mistake where I forgot to put the minus 1, but I actually worked out the sum correctly. So the question happens to have a minus, the dash for the minus is missing. So yeah, so when we look at this expression here, it's exactly the same as the expression here, except r over there is 1 minus p over here. So why don't we just use the exact same expression, which is equal to p times 1 over 1 minus p the whole square, right? Which is equal to p times 1 minus, what is 1 minus p? It's just p squared, right? Which is equal to 1 minus p. Therefore, we have expectation of a geometric is equal to just 1 over the parameter of the geometric. So that's how we prove this. And that's it for question 3 of homework 11.